Hello, health champions. Science is only beginning to uncover the importance of our gut health and our microbiome. And food can have a lot to do with that. So the first thing we need to understand is what to eat or not to eat so that we don't destroy the bacteria and upset that delicate balance. A couple of hundred years ago, they came up with something called the germ theory. They found out that there were microorganisms, pathogenic microorganisms, meaning germs and bugs that cause disease. But the problem is it was kind of a one-sided view. They only looked at bacteria and microorganisms as bad, and therefore they said basically just kill them all. They cause disease, so let's just eradicate them if we can. And so we started disinfecting surfaces, we started wiping everything down, we started cleaning things and putting chemicals and alcohol and solvents on surfaces. And then we found antibiotics, and it took about 60 years of antibiotics until 2001 when we started understanding more and more over a period of decades just how important there is with a balance of bacteria. So they coined the term microbiome to sort of help us understand that there's an ecosystem. Biome basically means an ecosystem, and we have a microscopic ecosystem in our gut that is hugely important. That bacteria are not bad, they can just be in balance or out of balance basically. Because our microbiome has an enormous influence on our metabolism, on our digestive function, and on our immunity. And the more they look, the more they find that our microbiome basically influences signaling and hormones and just about every function in the body. You want to think of a microbiome as a multi-species ecosystem. So there's a whole ecosystem living inside you, and there's hundreds or even thousands of different species down there. They're depending on you, but you're depending on them also. And when everything is working, everyone's kept in balance, then there is harmony in that system. You have about 40 trillion bacteria in your gut, and that's about the same number as the number of cells in your body. Depending on whose count you put the most faith in, the ones I've seen are about 40 trillion cells, 40 trillion bacteria. If you add that all up, that's about 5 pounds of bacteria, 2.5 kilograms of bacteria. That's a good bit. And then if we look at how much genetic material is it in there, so a human has about 23,000 genes, but if you add up the gene pool for all the things living in your gut, you get more than 100 times more genetic material, about 3 million genes between all of these different bacteria. And these 3 million genes, these thousands of species, they produce thousands of different metabolites, different waste products, different chemicals. Some of them benefit you. Some of those are vitamins or short-chain fatty acids, but others are toxic waste that you have to get rid of. And that's why it's so important to keep these things in balance. When the pathogenic bacteria start overgrowing, that's where you get an abundance of the toxic metabolites that can hurt you. And when you go to the bathroom, know that 60% of the dry matter of your feces, of your stool that ends up in the toilet, is actually bacteria. And once we have a balance, what we're looking for, there's somewhere around 85% of your bacteria should be the beneficial ones. And of those who can potentially be pathogenic and cause disease, those should be around 15. So as long as that ratio is in place, then the healthy ones are going to eat enough, are going to consume enough of the resources that they're going to sort of keep the pathogenic ones down. That's how we have balance. But if we eat the wrong things, or if we take antibiotics, or if something else hurts that balance, and then we get an overgrowth, now is where we get problems. Number one on the list would be sugar. And I hope, if you've been watching some of my videos, that you start getting the idea that sugar is not your friend. And especially we're talking about the glucose. So regular table sugar is 50% glucose, 50% fructose. And it's the glucose that is the primary fuel for these bacteria, because the vast majority of the bacteria in your gut are anaerobes, meaning they make their metabolism function without oxygen. And that means they primarily cleave glucose. They use sugar for energy. Some of these are obligate anaerobes, meaning that oxygen actually hurts them, but others are sort of where they can use either one, or even if they can't use oxygen, at least oxygen doesn't hurt them. So there's different classes, but the vast majority, 99 to 99.9%, function without oxygen, and that means they cannot use fat or protein. They have to use glucose, basically. And if we look for the fuel that's preferred by the different pathogenic versus beneficial, the glucose is more so preferred by the pathogenic, and fiber is more used by the beneficial. So if you're trying to re-establish balance, or if you're trying to feed the beneficial ones more so, then you want to eat things like leafy green vegetables, non-starchy vegetables, things with lots of fiber, but that are low in glucose. But also don't think that 100% of one is better and 0 of the other is better, because it's all about balance. We need all of them. It's kind of like sun versus rain, that most people probably want sun a lot of the time, but if you had 100% sun and no rain ever, that wouldn't work so well either. And if you're asking for rain and then you get 100% rain for a full year, then you get pretty tired of that. So everything works better in balance, and so does the microbiome. Food number 2 that destroys your microbiome is gluten. And we're talking about grains that contain gluten, specifically grains that are used to bake bread, because grains containing gluten are the only ones that can get the bread to rise. And wheat has been hybridized specifically to get huge amounts of gluten that makes the bread very, very fluffy. In Latin, gluten means glue. So it's the glue that holds the dough together to allow it to rise. But that also gives you an idea that glue is probably something that's going to maybe get you a little sticky on the inside, which is exactly what it does. And anything that has gluten is also going to be a grain with a lot of glucose. And we talked on the previous slide about how the glucose is what feeds a lot of these bacteria that you don't want. 80% of grain, for the most part, is glucose. It's starch that's basically just glucose linked together and very quickly starts breaking into glucose. The biggest focus on gluten has been because of people with celiac disease. And these are people with a severe allergy, a severe sensitivity, to where they have even a smidgen, just a crumb, a few milligrams of gluten, and their whole body just blows up. It reacts very violently. So for those people, you can't even have a crumb, but then it's all the other people. And there's something called non-celiac sensitivity. So even if you don't know that you're having a symptom, about 70% of the population are sensitive to gluten, and their reaction is going to vary. So some of these people know that they do a lot better avoiding gluten, and others it could be sort of subclinical. It hurts them, it causes a little inflammation, but they don't really knowingly suffer from it day to day. And then what about fiber? So glucose and fiber both feed bacteria, but it seems like the fiber is better at keeping a balance. So we can feed more of the beneficial bacteria with fiber. So back when humans didn't eat grain and we probably ate some tubers and some non-starchy vegetables and some leaves and some leafy greens, we probably got a ton of fiber and very little glucose. So if we look at these two breads, there's obviously a huge difference because this has virtually no fiber and all the glucose. This one still has almost the same amount of glucose, but it has tons of fiber. So that fiber is going to help offset the glucose in this loaf on top a little bit more. But again, it depends on where you are on your carbohydrate load. If you're insulin resistant, then either one of these two has way too much carbohydrates for you to be able to reverse that condition. Number 3 is fried food and fast food, processed foods. And someone noticed that they ate fast food and fried food for a week, and they checked their gut bacteria before and after, and they lost 33% of the species. So I don't know what that means in terms of upsetting the overall balance, but that's pretty dramatic, that you're killing off a lot of the species. And why is that a bad thing? Because the healthier your gut, the better the variety. That tends to always be the case. The more variety of species you have, the more input there is, the more they're able to balance each other. Other reasons to avoid fast food, fried food, processed food is that it's typically going to contain sugar, it's going to be lacking in fiber, it's going to have chemicals, preservatives, emulsifiers, artificial this or that, and the vast majority of it is also going to contain wheat, which has the gluten in it as well. Here's a headline I found when I was looking at this stuff. It said, "New study finds high-fat diet alters gut microbiome." So this was someone who had published an article referencing some study. And based on this headline, that looks pretty dramatic. That looks like high fat would be a really bad thing. But then when you look into it, it wasn't high fat, it was high in omega-6 polyunsaturated fatty acid. That means plant fats, processed plant fats. And then just to show how little they knew about what they were covering in this article, they went on to say that these high omega-6 oils were things like canola and flax oil. And I'm not a fan of canola, but it is not by far the highest in omega-6s. There are some that are far worse. And flax is one of the best oils, as long as it's not rancid. Flax has very, very little. It has 4 times more omega-3. It has the best omega-3 to omega-6 ratio of anything out there. So what they meant to say in the article, which they failed, is that the high omega-6 oils are the problem for the gut microbiome, but those are things like sunflower oil, safflower oil, soy, and corn oils, which have about 50 to 70% of all the fat in that oil is omega-6s. And this again illustrates that we have to understand enough about the basics so that we can understand if the bigger picture makes sense. Because otherwise they're always going to keep throwing things like this at us, and the headlines look so scary, but these are meant by people who are looking for sensationalism. They're looking for these things to scare us and upset us and confuse us. Number 4 is alcohol. And when we drink alcohol, especially large amounts, this is kind of dose dependent, it changes the microbiome. And they're not really sure about the exact mechanism, but there are a few things we know happen. Alcohol increases the intestinal permeability, so it makes the gut more leaky, and when things leak through, that causes more inflammation, more immune reactions, more sensitivities, and inflammation, as we know, is not a great thing for the gut. We also know that alcohol kills beneficial bacteria, so alcohol is a disinfectant. We use it to clean things. So obviously by the time it gets down there, it will be diluted, but it still can kill bacteria, especially beneficial ones. Food number 5 that destroys your gut is soy. it's been found that it interferes with the lactobacillus and the bifidobacteria. These are two of your most important beneficial ones. And soy is really interesting because it's one of these foods that have been promoted universally as a healthy thing. Just get more of it and you'll get healthier. And we got this idea from Japan primarily because they were eating more soy than the United States and the Western Europe, and they had less disease. So someone connected the two and said it's the soy. If you eat more soy, you get healthy. They didn't really look at all the other factors that the Japanese were eating way, way, way less sugar and grain, especially gluten grains. But we got the idea that soy was good. But we have to keep in mind that those countries where they ate more soy, they never ate it like this. They never eat it like we do. They eat organic and fermented back then when that was part of the culture. And then soy can be a good thing. Because if it's fermented, then it's partially broken down. There are enzymes and bacteria that are helping you digest it. And those cultures ate it primarily as tempeh, miso, kimchi, natto, etc. But when we eat it in the Western world, we first of all eat genetically modified because virtually all the soy grown is GMO. And then we eat it processed, right? We don't have enzymes and bacteria. We have industrial equipment and chemicals break it down. So they have things like textured vegetable protein, and it's used as an additive, and we eat soybean oil, etc. But that's not the way that it has been consumed. There was a reason these cultures used it for hundreds or thousands of years, and they learned that the fermented was the way to do it. There was a reason they figured that out, right? So soy is very, very difficult to break down, and it will do damage to your gut, among other things. Food number 6 is dairy. A lot of people I come across have sensitivities to dairy. It could be subtle, could be dramatic, and the most common thing is not lactose intolerance. It's because there are proteins in there that you develop sensitivities to. And some of those proteins can also be specifically irritating to the gut lining. They can promote leaky gut and irritation. And one of the biggest problems that we tolerate it so poorly is pasteurization. That means that they superheat it, they flash pasteurize. They heat the milk for a very short time, trying to kill off the bacteria. But when they do that, they also kill off all the enzymes and all the bacteria that you want that would help you digest that food. And in heating it, they also alter some of the proteins because proteins change configuration. They change properties when you heat them. That's how you cook meat, okay? The protein structure changes when you heat it. So I recommend that if you're going to do dairy, that you do raw or fermented primarily. In some states, it's legal to get raw milk. In others, it's not. And if you can't, then get fermented, which means that you buy yogurt or you make yogurt, you add some bacterial culture that can bring it back to life with all the enzymes and the bacteria in it. So these are things like yogurt and kefir and buttermilk. And also, I find that, at least in my clinic, that almost 100% of people do great with butter. Because what you're reacting to is primarily proteins. If you're lactose intolerant, it's in the sugar, but it's not the butter fat. It's not the milk fat that you're reacting to. And butter has just small, small traces of milk protein left, not enough to hurt the vast majority of people. If you are extremely sensitive or you just want to make it extra sure and play it safe, you can go for ghee, which is clarified butter, and then there is basically zero of those milk proteins left. And what about cheese? It is also a very common sensitivity, but it's not nearly as common as with pasteurized milk. I would say more than 90% of people do poorly on pasteurized milk. On cheese, I would say it's maybe 50-50, maybe even that 70% of people do pretty well on cheese, especially if it's a good quality, meaning not the slices with mixed in chemicals and milk and things like that, but a good quality aged cheese. Most people do okay. Food number 7 is GMOs. And whenever I bring that up, there's always a lot of people commenting and saying that, oh, there's no evidence for that. Well, here's how I look at it. I think it's safe to say that mankind has put some stress on planet Earth in the last few hundred years, right? We lived here, we didn't have much of an impact, but just in the last 200, 150 years, we've had a huge impact. We're talking how we're changing climate, we're influencing ecosystems, we're changing huge aspects of the planet. And most of that is because we're very short-sighted. We are often greedy, we have a lack of judgment of the impact in the longer term. In a sense, we love to play God. We think we're so smart that if we can change something, we should. But I think of it a little differently. I think no matter what you call the creator or your idea of the creator or whatever put this planet here, whatever mechanism or principle brought that by, I think that creator did something pretty much okay. I don't think that it's going to need our help. When it put all of the DNA in all the species together, I think that was pretty much okay. I don't think that it or he was looking for human help to speed up the process, to fix the things that the creator had failed. So when people say that there is no evidence, I would just say there's no evidence yet. And I think the magnitude of what we're playing with GMOs, it's on a scale where we can't afford to make a mistake. We can't afford to say, oops, 30 years down the road. And some of the other concerns are that a lot of the GMOs are grown with glyphosate, so there's another toxic chemical that's associated with these GMO foods. And we do know that there is such a thing as gene transfer. So when they're manipulating the genes in a plant that we're going to eat, they are creating a genetic sequence that never existed before. There's going to be some combination of genetic material that the world has never seen. And I think it happens a certain way by chance, and I think it happens sort of risky when we do it on purpose. And then these genes can shift. So these genes inside the food can transfer and move into bacteria. Remember, we have over 100 times more genetic material in our gut, and there is a definite possibility, even if it's not a probability, even if it doesn't happen in a year, maybe it happens in 30 years, who knows? But genes can transfer from the genetic material in food into the genetic material in the bacteria and now create species that we really don't want. And even if there's no definite evidence of health consequences, there is strong suggestions that this will disrupt the microbiome. Number 8 thing to avoid is tap water. And they do a great job of cleaning up and recycling water, but in that water there's going to be a tendency for bacteria to live. So on purpose, they add chlorine. And that's not a terrible idea because I'd rather have a little bit of chlorine than a really toxic bacterial soup coming out of my tap. So they add chlorine or something called chloramine. But think about why they're doing this. What's the purpose of adding chlorine to the water? It's to kill bacteria. So if it can kill the bacteria in the water, it can certainly also kill off some of the bacteria in your gut. So what we want to do is we want to let them add the chlorine to the tap water because that's a public health issue. but we have to remove the chlorine on our end with the filter. You could buy bottled water, but then you're typically going to be wasting a lot of plastic, and it's a much better way to actually get a home filter. If you can afford one, if you live in a place where you're going to be for a while, it's actually the cheapest in the long run is to get a whole house filter. You spend some more money up front, you're set for 5, 7, 8 years, and then you only replace filters very, very rarely. If you can't do a whole house right now, then you do the tap and the shower filter. Because if you shower, the chlorine in the water is going to be absorbed through your skin. So taking a shower for a few minutes is like drinking a few glasses of tap water, basically. And if you can't do the shower either, then just do the tap. Do at least that much. And it's especially important in certain areas where they use more chlorine. So where I live, for example, they will use a lot more chlorine in the summer because the warmer weather and the warmer water will grow more bacteria. When it's really cold, it's not so critical. But just know that they need to add chlorine and you need to take it out. Number 9 is antibiotics and hormones. So even though antibiotics are so hugely overused on humans, we're taking hundreds of times more than we need to, 80% of all antibiotics still go to animals, to things that we are producing for food. And it's kind of strange to me that almost every label I see says something like no antibiotics ever, no hormones ever. Everyone's denying that there's ever any hormones used in food, and yet these 80% of the antibiotics produced becomes 13 million kilos. And this is something that's usually a dose is measured in milligrams. So a whole course of antibiotics might be 1 gram or in the neighborhood on that scale. So that's 13 billion courses of antibiotics that are fed to animals. So there just doesn't seem to be a match between how much is being sold and the claims made. So am I saying that everyone's lying? No, I'm not saying everyone's lying, but I do think that there is a good chance of a lot of people lying about the labeling because this is so prevalent. And the best way, it's not guaranteed because they could be lying somewhat about that too, but the best way that you can protect yourself is to buy organic and do the research that you can about where the food comes from. Now here's an interesting one, because red meat was on every list that I found when they try to spell out the foods that hurt your bacterial flora, your microbiome. But then when you read through what they had to say about the red meat, none of them said that it hurt the microbiome. What they were saying was that the bacteria in your gut could produce something called TMAO, trimethylamine N oxide. So the name is not important, but this is a chemical that are made by your gut bacteria, and it uses raw materials that are primarily found in animal products like lecithin, carnitine, and choline. And all of these are important nutrients. So again, I think they're taking one little piece out of a haystack and blowing it out of proportion. So first they put it in a list that have foods that are supposed to hurt your microbiome. Then they say, no, it doesn't hurt your microbiome. It increases the levels of TMAO, and that is associated with cardiovascular disease, right? Again, they're taking one little piece out, but what I see is that the people who go low carb, high fat, the ones who cut back on sugar and grain, they typically eat more meat rather than less, and all of their health markers reverse. They scare us saying that it will cause cardiovascular disease, and yet we see the exact opposite. And not only in people's weight patterns and how they feel, but every single blood marker, the glucose, the A1C, the triglycerides, the insulin, all of the things that are important for cardiovascular disease, they actually get better when you eat more red meat rather than sugar and grains. So I think better questions that we would ask would be, what about the microbiome diversity? The people who had the cardiovascular disease and the higher levels of TMAO, what did their gut bacteria look like? Because if it's the gut bacteria that makes it, and they have an imbalance and they're eating too much sugar and grain, then that is probably going to affect the microbiome. And also we want to ask, if we eat that meat, did it come from a healthy animal? How was that raised? Does that meat have a healthy omega-6 to omega-3 ratio of 1:1, or is it grain-fed and have fats that contribute to insulin resistance? Number 10 thing to avoid is artificial sweeteners. And sugar and artificial sweeteners tend to show up in every single one of my videos because there's just nothing good about them. They are toxic. These are toxic in very, very small quantities. Sugar is toxic in high quantities. So based on research, they're not sure of the mechanism, but they have found very consistently that artificial sweeteners have an overall negative impact on your gut health. It has been shown that it does alter the microbe balance, the ratio of the different species. It contributes to glucose intolerance, the very thing that it's supposed to fix, that it's supposed to replace sugar so that you get healthier glucose handling. It actually worsens your glucose situation. Even though it has no glucose in it, it just messes with the physiology so badly. And it increases the rate of metabolic disease. And none of this is very surprising if we remember that the artificial sweeteners are basically all derived from pesticides. They're very chemically related to pesticides, things that are designed to kill other things. If you enjoyed this video, you're going to love that one. And if you truly want to master health by understanding how the body really works, make sure you subscribe, hit that bell, and turn on all the notifications so you never miss a life-saving video.